This is Srikanth, working as assistant professor in electrical department. Now I want to discuss about RLC parameters and their current and voltage relationship. So resistor, inductor, capacitor. We have three types of loads we have. Those are the passive elements. Here we have the resistor. Resistor is a passive element and it's a bilateral element also. And it's a lumped element also. So we have like different names for resistor, inductor and capacitor. For resistor, like you can use a different way. You can reduce the current flow, you can reduce the voltage, you can adjust the signal also. So you can use this resistor in different places. So resistor has some resistivity. For resistivity, we have the name the resistance. Okay. For resistance, the units is ohms. For resistance, formula is R equal to rho L by A. So here you can observe here, I have one resistor. So that means resistor is nothing but one conductor. So conductor has some resistance. So every conductor has some resistance. To measure that resistance, we have some formula. That formula is depending upon the conductor resistivity. So this is one conductor. The formula is depending upon this conductor length as well as this resistivity. And how much area is this conductor we have. Okay. So your resistance formula is rho L by A. So rho L by A. So rho is your conductor resistivity and L, that is the length of your conductor, and A is the area of your conductor. Okay. This is the symbol of your resistor. Suppose you want to draw any resistor. So you give the symbol like this and you can see resistor in outside like this. So physically resistor you can see like this with different color coding. Okay, color coding change means automatically the resistance value will be changed. Okay, this is one introduction about resistor. Now moving to color coding. So color coding means we have different type of colors we have. So for this color coding, we want to calculate what is the resistor value in general market. We have like this resistor. So like this resistor, I want to measure what is the range. What is the range of this resistor? So what is the value of this resistor? Unit is like ohms. Ohms means that is 1 ohm, 2 ohm, 3 ohm, 100 ohm, 1000 ohm, kilo ohms, mega ohms. How much this value? So depending upon the color, we have different values. We have different resistors also. So for this, we have color coding for resistors. So this is the range. You can see here 0. So black color is 0, brown color is 1, red color is 2, orange color is 3, yellow color is 4, green color is 5, and blue color is 6, violet color is 7, gray color is 8, white color is 9, and gold color is none, and silver color also none. But some tolerance we have 5% and 10%, and for red color we have the tolerance. So we have different colors. For every color we have some values. Okay, these are the values and these are the multipliers. So we have the values and multipliers and tolerance. So what is this? If you observe the resistor color coding here, so this is my color now, this is my resistor now. For this resistor, some gold color I have, and here brown, black, and some brown. Here red and gold color, and here yellow, violet, orange, and gold color. So suppose black means you can say like 0, brown means you can say like 1. Then if suppose for this, find out the value for this resistor means red color 2, again red 2, again red 2. This is the ohm for this resistor. No, this is the wrong. This is the wrong. So to measure the resistor values with color coding, we have some steps. Here we have only 1, 2, 3. So 3 band color resistors we have. Okay, like 3 band and as well as one tolerance band also we have. But if you have the 2 bands, if you have the 3 bands, if you have the 4 bands, 5 bands, 6 bands, then how will measure those resistor values? Okay, for that we have some steps. So if clearly observed, for black color is 0, okay, and multiplier is 1. So why this multiplier? And tolerance is 0. There is no tolerance. And brown color 1 and multiplier again 10. And red is 2, multiplier is 100. That means 10 square. This is 10 power 1 and this is 10 power 0. And here orange means 3. That means 10 power 3. Yellow means 10 power 4. And green means 5. That means 10 power 5. Blue 6, 10 power 6. And violet 7, 10 power 7. Gray 8, 10 power 8. White 9, 10 power 9. So we have different values and different multipliers. And coming to gold and silver, those are the tolerance. Why this tolerant means every resistor has some plus or minus values. So actually in temperature increase, automatically your resistor value will be increased. Okay, for this we have some plus or minus values. So that is tolerance percentage. 5% to 10% will be changed. The resistor value will be changed. Now we will calculate the resistor value using color coding. Now, suppose I have this resistor, simple resistor, and I want to find out the value of this resistor now. Okay, this is my simple resistor. This I want to find out the value. So for this, here I have the logics. How to find out the value of resistor. Okay, just observe now. Here we have 4 bands, 5 bands, 6 bands. We have different bands resistors we have in this figure. Okay, now check it now. This is so yellow color, violet color, red color. Then this is your silver color. So coming to silver, it's a tolerance. Okay, so just kept outside, that is your tolerance. So tolerance is silver. We have like how much percentage? That is 10%. Okay, that is outside, just kept outside. Now we have 3 colors: yellow, pink and red. We have 3 colors. So in 3 colors, yellow is the first one and your tolerance is the last one. Okay, yellow is the first one, then violet is second one, and red is your third one. We have 3 colors. Fourth one is your tolerance. So tolerance is outside. So we have now 3, that is yellow, violet as well as red color. We have 3 colors. Now before tolerance color, so before tolerance, that is your red color is your multiplier. So you need to consider the red color is multiplier value. So before tolerance, which color we have? That is your multiplier value. So this is your multiplier value. So red color is your multiplier value. So for multiplier, so what is the red color multiplier? That is 2. That means 10 power 2. That is 100 value. So we can write like 10 power square. So 10 square we have for red color. Then violet color and yellow color, both are values. Just you need to take the values. So for yellow color, which is the value? For yellow color we have the 4. And violet color, what is the value? That is 7. That's it. So 4, 7 into 10 power 2 is your resistor value. So this resistor, 4 band resistor value is 4, 7 into 10 power 2. That is a resistor value. And we have the tolerance, that is 10%. So 10% of tolerance. Okay. So now coming to like a same resistor, you can write like 4.7 kilo ohm. Kilo means 10 power 3. You can write like that also, no worries. Okay. So this is about 4 band. Then coming to 5th band, same procedure. Same as this procedure. Now, which is your tolerance? So I think this is a gold one. So gold one is your tolerance now. So this is your tolerance. This is the last one. And this is the first, second, third and fourth. So before tolerance, which value we have? That is your multiplier. That's it. So before tolerance, which color we have, that color value is your multiplier value. So now this is my red color. So red color is my multiplier value, and that value is red. Red is 10 power 2. 10 square is our value now. Now coming to remaining values. So blue as well as gray, blue color as well as gray color and black color, we want values. So for a blue color, that is 6, and gray color we have the 8, and black color we have the 0. And your gold color means you have the tolerance, that is 5% tolerance we have. So this is your value of a 5 band resistors, that is 68 kilo ohms. That's it. Same as like 6 bands, 6 bands, 7 bands, whatever, no problem. In practically, I have one resistor here. So this resistor, what is the value? We'll find out like using color coding. So which is the given tolerance now? My tolerance is like gold color. Gold color is my tolerance. So before gold color, that is my multiplier, and remaining are my values. So gold color, we have like this is a gold color. Gold color, we have 5% tolerance, and this is your red color. So before tolerance, the value is your multiplier. So red color multiplier is 10 square, and then black we have 0, and then brown we have 1. So we have 1 kilo ohms resistor. So when you have the market, you find like this resistor means that is 1 kilo ohm resistor. And moving to these resistors, so anyone, like consider anyone, same, this is why I want to find out what is the value of this resistor. So gold color again, so that is tolerance. So tolerance value is like 5% for gold color. Then before gold color, there is a red. Red is like 10 power 2, and then both are again red. So red means 2 and 2. So your value 2.2 kilo ohms. 2.2 kilo ohms for this resistor. Remaining also as it is. Okay. So this is about resistor values, color coding values. Now moving to current and voltage relationship. So we know that Ohm's law. From Ohm's law, V equal to I into R. That is from Ohm's law equation. R is your conductor. R is your conductor. So it's a constant temperature. V is directly proportional to I. Otherwise, I is directly proportional to V. So that is a condition. There R is your constant value. So the constant value is nothing but your resistance. So your conductor resistance. So we know that conductor resistance formula is rho L by A. That is your resistor resistance formula. Now moving to like values like current and relationship, current and voltage relationship. R equal to, from this equation, R equal to V by I, and V equal to I into R, and I equal to V by R. So this is about current and voltage relationship with respect to R. Okay, where we know that I is your voltage and R is your resistance and I is your current. Your resistance unit is ohms. Just remember, your units for resistance is ohms. Now coming to like inductor. Inductor also passive elements, and this is also bilateral elements. Where are the windings? That is nothing but your inductor. Where are the coils? That is also inductor. So fan, it's where the windings. So that is also inductor. Motor, that is also winding. That is also inductor. So we have different types of inductors we have. For every inductor, some inductance. So we need to measure that inductance using this formula. That is mu n square A by L. So what is the mu value? What is the n square value? What is the A value? What is the L value? So here, mu is nothing but your conductor. Which conductor you are utilizing? That conductor conductivity. Some I have the iron rod and you have some windings. So there we have some conductivity for this iron rod. Okay, and n square. So how many number of turns we have? That is nothing but your coil number of turns. And n, A is area. How much area you covered? So this is your some rod. You covered this much of area. So this area is your A value. So how many windings we have, that is N value. And length is not this length is your total wire length. So this is your L value. Okay, so inductance formula is mu N square A by L. And inductor store the energy in form of current. Inductor stores the energy in form of current. So we have for energy formula also for inductor, that is 1 by 2 into Li square. So 1 by 2 into Li square, store the energy in form of current, small current. Okay, so inductor stores the energy in form of current. Just remember this word, inductor store the energy in form of current. Okay, so your fan, when you switch off the fan also, it's rotated some rotation movement as well as store the energy in form of current, some current also we have. So this is about like your inductance, inductance, and the units of inductance is henries. Units is henries, H. We'll move to the current and voltage relationship in conductor now. So in inductor now, so inductor, I said inductor store the energy in form of current. So current means you can observe the voltage equation. So it store the energy in form of current. So di by dt, small current. We have like from Ohm's law we have V equal to I into R for resistance. So same thing here, inductor here, but your current, which current we have, that current is small current. So we could write like V equal to L di by dt. Okay, so this is about your voltage. So from this equation you can solve like I equal to 1 by L integral V dt. So apply both side integral, we have the value I equal to 1 by L integral V dt. So for your inductor, we have the inductance, and the inductance value is mu N square A by L, and energy is 1 by 2 Li square. And coming to like voltage equation is V equal to L di by dt, and I equal to 1 by L integral V dt. And this is the symbol of your inductor symbol. And maximum you can use like this inductors in filters, sensors, motors, anywhere. Maximum where the winding you can see this inductor. And moving to like capacitor, so this is also one passive element, and this is also bilateral element. So where you have the AC voltages, AC capacitor, there you can say this is the bilateral element. For DC we have the AC and DC capacitor, different capacitor. For DC it's not bilateral element, for AC it's a bilateral element. And it's the store the energy, the capacitor store the energy in form of voltage, and capacitor has some capacitance, that units is farads. Okay, so every capacitor has some capacitance, that units is farad. And now, so how we'll measure the capacitance means epsilon A by D. What is the epsilon and what is the A and what is the D? So epsilon is nothing but which plates you are using in capacitor. For capacitor you need to use some different plates, like silver plates, or paper also they are using some small capacitors. Okay, so every plate we have some conductivity, that is epsilon naught, and the area, which area, how much area you covered. So how much area we have for that plates, between the plates, that area is your A, and D was your distance, how much distance you are covered. So how much distance we have both plates. So we have two plates, the distance and area, and the plate conductivity. Now the symbol of capacitor is like this. So two plates between the capacitor, and you can observe in outside like this capacitors in the market. You can see like this capacitor. Okay, depending upon different capacitance values and voltage values, we have different capacitors we have. Now moving to voltage and current relationship, capacitor I said store the energy in form of voltage. Inductor store the energy form of current. So 1 by 2 Li square for inductance, 1 by 2 CV square for capacitance. So storage the form of voltage. So the capacitor store the form of in voltage means I need to show that small voltage dV by dt. So dV by dt. So I need to write the equation for current I equal to C dV by dt. So C is your capacitor. So capacitance value and I is your current and small voltage. So capacitor stored in form of small voltage means so I need to show the voltage value dV by dt and my equation for current is C dV by dt. And apply the Bose integral, we'll get like V value, V equal to 1 by C integral I dt. So reverse of your inductor and resistor. Okay, your capacitance value this is and your energy value, capacitor energy value is 1 by 2 CV square and this is your symbol and this is the voltage and current equations. Okay, and where we have the sensors, where you have the like energy storing devices, there you can use these capacitors, and where you have the mosquito bats, there also have the capacitors, some energy devices. So this is about like capacitor and coming to overall. So resistor, current and voltage and current relationship, V equal to I into R, I equal to V by R. For coming to inductor V equal to L di by dt and I equal to L 1 by L integral V dt, and for resistance value is R equal to rho L by A and inductance value is mu n square A by L and energy is 1 by 2 Li square. Same as for capacitor, V equal to here 1 by C I dt. So reverse of inductor. So here I equal to 1 by L V dt, but here V equal to 1 by C I dt. Okay, and I is C di by dt. So why we didn't write dV by dt and here di by dt means inductance store the energy in form of current and capacitor store the energy in form of voltage. So I have the current, so I write the equation for voltage. I have the voltage and I write the equation for current. That's it. Just remember like that. Okay, and capacitance formula epsilon naught A by D and energy is 1 by 2 CV square. So this is about voltage and current relationship between RLC parameters. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.